today's problem from arc length, and the problem is give a rough sketch of the cardioid R. This is equal to A into 1 plus cos theta, and express in term of theta the actual distance measured from the origin up to the current point R theta. Okay, so we have to first draw a rough sketch of the curve cardioid, and we have to find the length from the origin to any point or current point R theta. And also it is given that prove also that the point on the cardioid whose vectorial angle is pi by 3 is the middle point of the upper half. Okay, so if theta equal to pi by 3, this is the middle point of the upper half. Finally calculate the total length of the curve. Okay, here we write the result we use here. The arc length of the polar curve R, this is equal to f of theta, is given by arc is given by S. This is integration theta 1 to theta 2 root under r square plus dr d theta whole square d theta. This is the formula of arc length of the polar curve. Okay, now we first try to draw a rough sketch of R equal to A into 1 plus cos theta. Here R, this is equal to A into 1 plus cos theta. Since this is a polar curve, so we first draw a pole and a initial line. This is pole O and this is the initial line OX. Okay, now we first put or replace theta by minus theta, and it is clear that this is unchanged if we replace theta by minus theta, and this relation gives theta, this is equal to minus theta, this is theta equal to 0. About this line the curve is symmetrical. And what is theta equal to 0? This is the initial line. Okay, so the curve is symmetrical about the initial line. So the curve is similar as upper of the initial line and lower of the initial line, right? And now if we put theta, this is equal to 0 here, we get the value of R, this is equal to A into 1 plus 1, this is equal to 2A. And if we put theta, this is equal to pi by 2, here we draw the perpendicular line, here theta, this is equal to pi by 2. And if we draw the opposite to the initial line, this line, and here theta equal to pi. Okay, here we put first theta equal to pi by 2, then getting the result R, this is equal to A into 1 plus 0, so this is A. And if we put theta equal to pi, here we get theta equal to pi, R, this is equal to A into 1 minus 1, because cos pi equal to minus 1, so this is 0. Okay, so we get three important points. The first point is theta equal to 0, R equal to 2A. So we let this point is this is 2A comma 0. Okay, because in polar coordinate the coordinate is r theta. The first is radius vector and second one is vectorial angle. And the second is when theta equal to pi by 2, the point is pi by 2 and A, so this is A and pi by 2. And the last point is theta equal to pi, this is theta equal to pi. Okay, this line is theta equal to pi, and theta equal to pi when r equal to 0. And so this is 0 and pi. So the rough sketch of this curve is like this. Okay, and because of symmetry about the line theta equal to 0, we draw the sketch in the lower part as similar as upper part. Okay, so this is the rough sketch of R, this is equal to A into 1 plus cos theta, right? This is the cardioid, and this method is known as curve tracing. Okay, this way we trace the curve and we draw the rough sketch of cardioid. Now we have to find the arc length from origin to the current point. That is, current point means if we take this is P, this is R theta, and this is origin. Okay, so here theta equal to 0 and here theta equal to theta, we get arc length from theta this is equal to 0 to theta this is equal to, this is given by theta. We get S, this is equal to integration theta equal to 0 to theta root under 1 plus, sorry, this is r square plus dr d theta whole square d theta. Okay, here dr d theta, this is given by minus a sin theta. So we put the value of dr d theta and r here, get the result as 0 to theta root under r square means square into 1 plus cos theta whole square plus this is a square into sin square theta d theta. Okay, so we get a into integration 0 to theta root under 1 plus 2 cos theta plus this is cos square theta, this is sin square theta, so this means 1, and by taking common 2 we get the result as a into root 2 into integration 0 to theta root under 1 plus cos theta d theta, and getting the result a root 2, and from this relation we get another root 2, so we get 2a, because this the formula is 2 into sin square theta by 2. Okay, so we get the result as integration 0 to theta, sorry, this is 2 into cos square theta by 2, so we get 2a into 0 to theta, this is cos theta by 2 d theta, and integrating we get this is 2a by half into sin theta by 2, and the ranges are 0 to theta, so this is 4a into sin theta by 2. This is the arc length from origin to the current point r theta. Okay, and this is our first answer. Now to prove the second part, here it is given that prove also that the cardioid, the point on the cardioid whose vectorial angle is pi by 3 is the middle point of the upper half. It is clear that the middle point of the upper half we have to prove at the point theta equal to pi by 3. So we have to find the total length of the upper half. Here we integrate from theta equal to 0 to theta equal to pi, because the upper half is from theta equal to 0 to theta equal to pi. So length of upper half, length of upper half is, or we write length of total upper half, or we write here, so total length of upper half. Okay, total length of upper half is S1, we name this is S1, and now we have only to change the limit of integration. Here we put 4a sin theta by 2, here with theta equal to 0 to theta equal to pi. Okay, and getting the result as 4a into sin pi by 2, so this is equal to 4a into 1, so this is 4a. This is the total length of the upper half. Okay, now let the length from theta equal to 0 to theta equal to pi by 3, this is S2. Here S2 is the length from theta equal to 0 to theta equal to pi by 3, and which is given by 4a into sin theta by 2, and the range is 0 to pi by 3. Clear? So we get 4a into sin pi by 6, that is 4a into half, this is 2a, and from these two results it is clear that S1 this is equal to 2 S2. Okay, and this proves the second part, because the vectorial angle pi by 3 is the middle point of the upper half. So we write here the second answer. Now finally we have to calculate the total length of the curve. How to find the total length of the curve? Because of symmetry about the line theta equal to 0, that is about the line initial line, so we get the total length. Total length is given by, total length is S. S is given by 2 into S1 because this is double of upper half. Okay, so we get 2 into 4a, this is 8a, right? So the total length of the upper half we get, this is 8a, and this is the answer number 3 or final answer. So we get very easily 3 answers. First one is the sketch or rough sketch of the cardioid. Second one is to find that theta equal to pi by 3 is the middle point of the upper half. And the last result or final result of this problem is total length is equal to 8a. Okay, very important problem of arc length. Thank you for watching.